Alright, welcome to our exam review for Exam 4, Math for Liberal Arts. The usual disclaimer here as we're getting started. These videos are copyrighted. Please don't upload them to the internet where they can be sold or redistributed. So we're starting off here with our different voting methods, and I give you a preference ballot here for voters. And 12 of them voted A, C, D, B in that order, 10 B, D, C, A, 5 D, A, B, C, and 3 of them D, C, B, A. So these are all different orderings here. And I want you to determine the winner using first a board account and then next plurality with elimination. Okay, so remember the board account's the point system. So you get 4 points for first place, 3 for second, 2 for third, and 1 for fourth. So if we're setting up a board account, we're going to do a count for A, 1 for B, 1 for C, and then 1 for D. And each one of these counts, remember, is number of first place votes times 4 points for each first place, plus number of second place votes times 3 points for each second place vote, plus the number of third place votes, or number of ballots that placed it third, times 2 points for each third place vote, times number of fourth place votes, and then each fourth gets 1 point. So it's that point system. So this part's going to be, this general structure is going to be the same all the way down. I'm just going to copy this, and then we'll just fill in the numbers. They'll be a little bit different here as we get down. Just the number of votes, but the points for each vote stays the same. So let's see here. Okay, so A, let's look at A first. So number of first place votes, we're just looking at the first place row. A was voted first on 12 ballots, so 12 goes in here. Second place votes, A's in the second column here on 5 ballots, so 5 second place votes. Third place votes, no A's in the third place column, third place row. Fourth place votes, 10 ballots here voted A fourth, and then 3 ballots here voted A fourth. So 10 plus 3, 13. And we add those guys up. Alright, so let's add these guys up. So we got 4 times 12 here is 48, plus 15. And, oh wait, I didn't fill in our third place votes. That was 0. Yeah, that's why I didn't fill it in. 0 and then 13. So that gives us a total of 76 points for A. Now for B, first place votes, B on 10 ballots. So that's a 10 in there. Second place votes for B, none. So this is a 0. Third place votes for B, it was third on 5 ballots here and 3 here. So that's 8. And fourth place votes for B, looking in the fourth place row, 12 ballots. So this is 40, plus 0, plus 16, and plus 12. And that's 68. So 68 points. So far A is winning. Look at C. So C is voted first place 0 times. No first place votes for C. Darn. Second place, 12 ballots here and another 3 there. So 15 ballots voted B second. Third place, I got 10 ballots here, and that's it. And then fourth place, 5 ballots voted C fourth. So we got a 0 here. 3 times 15 is 45. Another 20. and then another 5. And that's 70. So even though C got no first place votes, it's still ahead of B. How about that? It's because it got a lot of second place votes. Okay, and then D had 5 and 3, 8 ballots that voted D first. Second place votes, 10 ballots there. That's all the D's in the second place. Third, we got 12 ballots here. Looks like that's it. And then fourth place, no D's in fourth, so a 0 over here. Okay, so 4 times 8, that's 32, and 30, and 24, and 0. So 86. And highest number of points wins, which is D. Okay, so D wins a board account. Right there. Alright, and then the next one here, we're doing plurality with elimination. And so that's, remember, that's the one where you eliminate the lowest number of first place votes. So I'm going to start from this table. And actually, let me just copy this guy down here. Okay, so this is going to be for part B. So lowest number of first place votes, A, B, and D all got first place votes. C has no firsts. So remember with plurality with elimination here, what you do is you eliminate the one with the lowest number of firsts at each stage. Lowest number of first place votes. Well, C is nowhere in the first place row. So C got no first place votes. That was this 0 right here. So C gets eliminated. So gone, 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 gone. So C is done, goes home for winter break. Alright, so now we're going to redraw this table. And we've got our rank. And we eliminated one candidate, so all we've got left is first, second, third. And we moved D and B up. So this is 12 people that voted A, D, B. So 12 ballots now will look like A, D, and B if C drops out of the race. 10 ballots will be BDA. So 10 here are B, D, and A. 5 ballots are DAB. And then 3 ballots are DBA. And double check to see if you have any repeats, and these guys are all different ballots, so otherwise you could combine. So now we look for least number of firsts again. A has got 12, B has got 10, and D has got 8. So D has the lowest number of firsts, so goodbye D. Okay, and then we go to our next table. So let's see here. Just going to have first and second now as our ranks. And if D drops out, we've got 12 ballots that are AB. And then we've got 10 ballots here that are BA. And then these 5 ballots will turn into an AB. And then these 3 ballots will turn into a BA. Okay, and then we want to combine. So these ballots are the same and these ballots are the same. So I'll go ahead and redo the table here one last time. And we got rank up here. So these 12 ballots plus these 5 is 17 that are AB. And then these 10 and 3, 13 that are BA. And then we eliminate the lowest number first. B has got the lowest number first here, so A wins. Okay, so that's part B. Part C, determine the rankings using plurality with elimination. Okay, so the rankings are going to be first, second, third, fourth place in order. So A1, because it got eliminated last, or it didn't get eliminated at all. Okay, so A1. The second place was B, because it was eliminated last. And then we go back here, go back another table. D was the next one. So D got eliminated second to last. And then C was the first one to get eliminated, so it was in last place. Okay, so this is the reverse order of elimination. So they got eliminated C, D, B, and then A was left. So here, C, D, B, A. So you just reverse the order of elimination. And then I didn't ask for this in this problem, but if we did rankings up here, D would be first, of course, and then you just go down by points. So next would be A, and then next would be C with 70, and then last place would be B. All right, so I got two voting methods out of the way. Okay, and now we are looking at almost the same ballot, except I changed number of ballots up here, so we've got a tie between A and B. So I say determine the winner using plurality, and remember plurality is the greatest number of firsts. So in part A here, you've got a tie between A and B. They tie with 10 each. And then D only has 8. So, and then C has no first place votes. And then we want to break that tie using pairwise competitions. Okay, so part B here, we're doing pairwise competitions. So remember how you determine your different competitions here. You've got A, B, C, D, and you want all possibilities of one candidate versus another. So let's see here. We could have A versus B, A versus C, A versus D. B to A we've already got. B versus C, B versus D, and then C versus D. You know what? I can't remember if I did those different last time. Did I do this? A versus B, A versus C, A versus D. B to A we've already got. B to C, B to D, C to A and C to B we've got. C to D, and then D is already connected with everything else. So A to B. So we're looking at how many first place votes. If we eliminate the other two candidates, we only pay attention to A and B. How many times is A over B? And then versus how many times B is over A. So 10 ballots here, A is over B. That's B over A. 5 more, A over B, and then B over A. So 10 and 5, 15. That 15 times that A wins over B. And then the number of times that B wins over A is going to be the switched ones here. So B over A is 10 there, and B over A is 3 there, so 13. So 15 to 13. And 15 is higher, so A wins that pairwise. Then we've got A to That's A to B. Then we got A to C. Why don't we just list all these out to start? A to C. Then we've got A to D. And then let's see, B to C, B to D. And then C to D. Okay, so let's see, A over C, 10 times there, that switches, 5 more times there, and that switches. So this is going to be a 15 to 13 again. They have to total to 28 because here your total votes here 10, 20, 25, 28. Your total is 28. So these two numbers have to always total to 28. So once you know one of the numbers, you know the other. So A wins that one also. I'm putting the winner off to the side here. So A wins. And then out of these two, A wins. A to D. So A over D, that switches, switches, switches. So A over D is only 10 times. To D over A is the other ones. So 10 and 5 and 3. So that's 18. So D wins that one. B to C. So let's see. This is C over B. B over C 10 times there. B over C there. 5 times, and then it switches. So these are B over C 15. And what's left is going to be the 13. C over B 10 times here, and then C over B 3 times here. So 15. B wins that one. B to D. So let's see, B over D. This is D over B. B over D 10 times there. Switches, switches, so just 10. So this is going to be 10. And the other one's going to be 18. It's going to be like this, 10 to 18. So 18 wins. D wins that one. Because I know these got to total up to 28. That's our total. So if this was 10, that had to be 18. C to D, last one. So C is over D there. Switches. Switched, switched. So only 10 times that C is over D. And so that would leave 18 for the other. So 10 to 18. And 18 wins. D wins that one. Okay, so we didn't have any ties in here. So remember, if you have a tie, you don't count it. But D won 1, 2, 3. So D wins 3 of these guys. D wins 3 competitions, or 3 times. See, A wins 2 of them. A wins 2. B wins 1. And then C didn't win any. So C wins 0. Okay, so D is our overall winner right there. So that breaks the tie. So A and... I'm sorry. We did not have to consider one of these because we were tie breaking. A and B were in the tie. So we only consider the competitions that involve A and B. So we didn't need this last competition. Okay, so let me back up here. Sorry about that. This would be if you were just doing an overall pairwise competitions. So let's see, we actually do not need C to D because that competition does not involve A or B. All the rest of these involve A or B, or both. So it's this last one we don't need. Okay, so we didn't need this. Okay, so now D wins 2 of these. and A wins 2, and B wins 1, and C wins 0. But we're just looking at these guys right here between A and B because we want to break a tie between them. So we're only concerned with how many competitions A wins and how many of them B wins. Well, A wins 2 right here. Okay, so A wins the tie. Okay, so that's how you break a tie. You would include this last one if we weren't breaking a tie, if we were just doing like an overall winner of all 4. Okay, and then next up we got an approval ballot. So this is where you vote for more than one candidate, but it's, each candidate, you can have multiple winners, depending on what your criterion are here. So we had 20 ballots where people voted for A and D, 12 ballots where they voted for A, C, and D, 8 where they voted for C and E, and 5 ballots were A, C, D, and then 2 ballots were B and E. So first, how many ballots were cast? Well, that's just going to be the total up here. So actually here, we're going to put one more column on here, which is our total. And let's see, 20 and 12 is 32, and 8 is 40, 45, and 2, 47. So 47 ballots total. The overall winner, A got voted for 20 times here, 12 times here, so that's 32, and 5 is 37. So that's the total votes for A, is 37. And B only got 2 votes here on those ballots. Oh, sucks to be B, huh? C got 12 votes here, and 8 votes here, and 5 more here. So 12 and 8 is 20, and 5 more is 25. And D got 20 votes here, 12 votes on these ballots, and then 5 votes here. So 20 and 12, 32, and 5, 37. And then E got 8 votes from these ballots, and then 2 more from those. So 8 and 2, 10. So overall winner, we've got a tie, 37 to 37. Okay, so it's a tie between A and D. Okay, so it's possible to have a tie. Top 3 candidates, so we had 37, 37, and then the 25. So that would be A, D, and C. And then determine the winners if you need 75% of the votes to win. So what you could do is you could add one extra column here if you want, and then do the percent. So to get the percent, you just take these numbers, the total, and divide by 47. So if you do 37 divide by 47, you get 0.787, so like 0.79. So this will also be a 0.79. 2 divided by 47 is not going to be enough. Yeah, it's a 0.04, 4%. 25 divided by 37. I'm sorry, divide by 47. I don't think that's going to be enough either. 53. And then 10 is not going to be enough. 10 divided by 47. Yeah, they got 21%. So if you need at least 75%, that's the 2 79s, which were the A and D. So this is A and D. Okay, so that's approval voting. Name a common weighted voting system and its quota. Most common and important weighted voting system is Electoral College for our presidential elections. And remember, that's where each state gets a certain number of votes, one for each senator, one for each representative. Its quota is 270. Okay, so that's just an important memory question there. Okay, more of the weighted voting systems here. You got a corporation with 6 shareholders, and they own 52%, 36%, 6, 3, 2, and 1% of stock respectively. You got a majority that's needed to win or pass a measure. So represent the voting system. So you put the quota first, and majority is the quota. So 52 and 36, I think these add up to 100. 52 plus 36 plus 6 plus 3 plus 2 plus 1 is 100. Yeah, so these total up to 100. So majority here is going to be 51. So these total to 100. Total equals 100. So you need more than 50% of the vote will be majority. So 51 is your quota. And then you just put the number of votes for each one. So voter 1 has 52 votes. 52% would be 52 out of 100, every 100. 36 for voter 2, 6 for voter 3, 3 for voter 4, 2 for voter 5, and 1 for voter 6. So that's the weighted voting system. So that part's done. Any dictators? Dictators here mean that their votes are greater than the quota. Okay, votes are greater than the quota Q. Our quota is right here to 51. That's our quota. And voter 1 here has 52 votes, which is greater than the quota. Yeah, so V1, voter 1, is a dictator. Whatever they vote, it passes, because they've got more than half the votes all by themselves. Any dummies here? Anybody that would not have any power on the outcome of the election? Well, yeah, since voter 1 is a dictator, whatever they say goes. In fact, if all the rest of the voters got together, voter 2 here, got voter 3, got voter 4, and voter 5, and voter 6. And remember, a dummy is a voter that has no influence, no power in the election. So, voter 1, it doesn't matter what they do. I'm sorry, voter 6, it doesn't matter what they do, because voter 1's a dictator. So whatever they say goes. Same thing with voter 5 and voter 4 and 3 and 2. Since we've got this, this dictator here, all these guys are dummies. They don't have any power. And that's kind of what a dictator means, is that nobody else has any power. So yeah, so the dummies here are going to be V2, V3, V4, V5, and V6. So all those guys, it doesn't matter what they do, they have no influence on the election. Even if they all get together in a coalition, they still can't pass a measure. Okay, it's just everything is on whatever voter 1 does. Now, just as a little side example here, let's look at problem number 6 for a second. Here our quota is 60, and here we've got voter 1, voter 2, voter 3, voter 4, voter 5, and voter 6. Got 6 voters again. And now here there's no dictators. So I didn't ask this, but notice here that there's no dictators because the quota is 60. Nobody has over 60 votes. So here there's no dictators. Now for dummies, let's look around for dummies here. Yeah, I don't know. This 5 looks pretty stupid. What do you think? Is the 5 needed anywhere? Either of these 5s, are they needed in any type of a coalition to get a vote? or I'm sorry, any type of coalition to get it to pass, get a vote to pass, or a measure to pass. Well, let's see, if 41 and 22, if they put theirs together, they've got more than the 60. And if you lacked one of their 2 votes, then a measure wouldn't pass. So those guys aren't dummies. The 41, let's see, the 41 and the 17 would not be enough to pass. But let's see here. If you did, yeah, because that'd be 58. You wouldn't have enough to pass. You'd have to add someone else in. So if you did the 41, the 17, and one of the 5s, then you could get a measure to pass. Okay, because 41 and 17 would be 58, and then a 5 would push it up to 63. So yeah, so these 5s here are actually not dummies. Okay, they do have some power in the election, because if they were to get in a coalition with, the first voter and the third voter, then they would be able to help pass a measure. Okay, that doesn't happen up here. Everything's controlled by that guy. So no dictators, no dummies in that one. Okay, and then down here, does any voter have veto power? So that means if that voter withholds their vote, then the measure won't pass. Well, you need 60 to pass. Okay, so you start with veto power, you always start with the highest voter. So if voter 1 withholds their votes for their 41 votes, let's see, the total of these guys, 41 plus 22 plus 17 plus 10 plus 5 plus 5 helps if you turn your calculator on. Is 100. Okay, so the total of these guys is 100. So this is 41 here. These guys, they add up to 59. Okay, so all of these guys together here, 59. They've only got 59 votes. So even if all 5 of these guys get together, they can't pass a measure without voter 1. Because they've only got 51 votes and you need 60 to pass something. So this would be called a supermajority. So voter 1 does have veto power. Okay, if they withhold their vote, then the measure will not pass because these guys can't get together and get enough votes. List a winning coalition. So there's a whole bunch of winning coalitions. We just want to list one of them. So for example, voter 1 and voter 2, if they get together, they have 63 votes. Okay, so that would be enough to pass something. So voter 1 and voter 2, that'd be a winning coalition. And there's lots of other ones, but all of them would have to include voter 1 since they got veto power. You could do voter 1 with 4, 5, and 6, because this is 20 votes along with 41, that'd be 61, so this would be another one. So voter 1, voter 4, voter 5, and voter 6. That'd be another winning coalition. Blocking coalition. It's a group of 1 or more voters that get together to block a measure. So since voter 1 has veto power, that would be an example of a blocking coalition. So just voter 1. That could be one blocking coalition. Or anybody else that totals up to at least 40, okay, because you need 60 votes. So if you can get at least 40 votes against it, then it's not going to pass. Well, actually, more than 40. You have to get 41 votes against. So let's see, if we put the 22 together here with these guys total to 20. Along with 22 would be 42 against. So that would be a blocking coalition. So another blocking coalition would be V2 along with 4, 5, and 6. V4, V5, and V6. Because see, this is 41 no votes. And then these guys added together, that was 42 no votes. Okay, so those are two examples of blocking coalitions. So I only asked for one, but I'm trying to give you more examples here. Okay, and now we're up to Banzhaf, the old Banzhaf power index. So remember, there's 4 headings. You just have to remember your headings for Banzhaf power index. First, you list your different coalitions here. And then you list the coalition weight. So you add the number of votes together. And then you tell me, is it win or lose? And then you identify critical voters. So Banzhaf deals with the critical voters. Okay. And the critical voters are the ones that if they withdraw their vote, then it goes from win to lose. Okay. So critical means without the measure goes from win to lose. Okay, you need their vote to pass the measure. Okay, so we'll list our different coalitions here. So we've got 3 voters. So voter 1, voter 2, and voter 3. And then our quota is 12. And so we could have 1-person coalitions, so V1 or V2 or V3. Or we could have 2-person coalitions, so we could have V1 and V2, or V1 V3, or V2 V3, or we could have a 3-person coalition, V1, 2, and 3. And again, I'm just going to do, for you guys, I'm just going to do 3 voters. Okay, so you're going to have 3, 6, 7 different coalitions for Banzhaf. The coalition weight, so the number of votes for voter 1 is 9. For voter 2, it's 5. And for voter 3, it's 4. So I'm just looking right here. Now, if 1 and 2 get together, they've got 9 and 5, 14 votes. If 1 and 3 get together, 9 and 4, which is 13 votes. If 2 and 3 get together, 5 and 4, 9 votes. And if everybody gets together, this is 9 and another 9, 18 votes altogether. And then we need 12 votes to pass the measure. So anybody that's above 12 is a winning coalition. So 9 is less than 12, so that loses. 5 is less than 12, that loses here. Win is greater than or equal to 12. That's how we're determining. So that's losing, 14 wins, 13 wins, 9 is losing, and then 18 wins. Okay, then when you determine the critical vote, the critical voters, without their vote, the measure goes from win to lose. So if it's already a lose, we don't even consider those. There's no critical voters. So we only consider the winning coalitions. So this first coalition, you've got 14 votes total. So you ask, if either one of those voters withholds their votes, does this go from a win to a lose? So, well, it's 9 and 5. If the 9 withholds, you've only got 5 left, not enough to pass. If the 5 withholds, you've only got 9 left, not enough to pass. So both of these voters are critical. So V1 and V2 are both critical there. With V1, V3, so you've got 9 and 4. And again, if the voter 1 withholds their 9 votes, you've only got 4, not enough to pass. If these 4 votes are withheld, you've got 9, not enough to pass. So both those guys are critical. You need them for the measure to pass. And then if we get all 3 voters together, you ask, okay, can anyone withhold their vote and have it still pass? So if we got all 3 of these together, If voter 1 withholds their 9, we've only got 9 left here. Not enough to pass, so they're critical. If voter 2, so voter 1 is critical here. If voter 2 withholds their 5 votes, we've still got 9 and 4, 13, which is enough to pass. So they're not critical. And if voter 4 withholds their 4 votes, we've still got 9 and 5, 14. That's enough to pass. So voter 1's the only critical voter in that coalition. And then bonds off, you do critical over the total number of critical voters. So the bonds off power index for voter 1 is going to be number times voter 1's critical, which is 2, out of 1, 2, 3, 4, 5. 5 times that a voter can be critical total. And so that's 2/5 is 0.4, 40%. And then the bonds off power index for voter 2 is going to be number times that voter 2 is critical. There's only one V2 there. And so that's 1 out of 5 total number times any voter is critical. That's 20%. So they've got 20% of the power. And then voter 3, their power is going to be number times voter 3 is critical. Oh, you know what? I'm sorry. I made a mistake here. This is 3/5. 1, 2, 3 times that V1 occurs. Sorry about that. So this is a 3/5, which actually makes this 60%. Number times voter 1 is critical. 1, 2, 3 out of 5 total that a voter can be critical. So that's a 0.6. Number of times V2 is critical. 1 time you see V2 over here out of 5. So 1/5, 0.2. Number times voter 3 is critical. 1 time right here out of 1, 2, 3, 4, 5. So that's 1/5, which is 0.2. And these guys add up. 0.6, 0.2, 0.2 is 1.0, which is 100%. So this should always add up to 1. I would have realized that I did something wrong if I left that as a 0.4, because these wouldn't have added up to 1. And I said, uh-oh, we better go back and check. So if your numbers don't add up to 1 here, go back and double check your work. Okay, and then the other way to determine power was this Shapley-Shubik power index. And you only had 3 columns here. And this one is the one that dealt with pivotal voters. And you listed all possible sequential coalitions. We called those permutations of voters, so orderings. So permutations was the mathematical word, but orderings of the voters. And then the second column was the weights, individual weights of each of the 3 voters. And then the last column asked which voter was pivotal. So as you went from left to right, pivotal is the voter that takes it from a lose to a win. So Bonshoff, if you take them away, it loses. Pivotal, when you add them, it wins. The measure wins. So then your permutations, you'll start with V1, and then it could be V2, V3. So that's one coalition, that order. Or you could start with V1, and then these could switch. You could add V3 next, and then add V2. The coalitions that start with V2 could be V2 first, V1 second, V3 third. Or you could start with V2 and do voter 3 next, and then voter 1. So I just switched these guys. And then 2 of them that start with V3. So we've got V3, and then you could do V1, V2. Or you could start with V3, and you could do V2, V1. Okay, the weights, just list out those weights in order. So here's our quota. And then this is voter 1, voter 2, and voter 3. So 1, 2, 3, those weights in order would be 9, 5, 4. 1, 3, 2 would be 9, 4, 5 in order. 2, 1, 3, so 5, 9, 4. 9, 4. 2, 3, 1, so 5, 4, 9. 3, 1, 2, so 3 is, so it'd be 4 votes, 9 votes, and then 5, so 4, 9, 5. And then 3, 2, 1 is going to be 4, 5, 9 in that order. Okay, and then you just go left to right and you add up the numbers, and here pivotal, lose to win, we need greater than the quota. We need greater than 12. Actually greater than equal 12. Excuse me. So 9 votes is not enough. But now when you do 9 plus 5, so first you consider just the first number. Now if you add the first two numbers, 9 and 5, you get 14. 14 is greater than 12. So 5, that second voter, voter 2, is pivotal because they push it to a win. So voter 2 is pivotal in that ordering. In this ordering, voter 1 gets 9 votes, not enough to pass. But then when you add in these 4 votes, so now if you do the first 2, 9 and 4 is 13, that's bigger than 12. So when you add that 4, it changes it to a win, so voter 3 is pivotal. And you only have one pivotal voter. Up here, when we were doing critical voters, you could have more than one that was critical, but you're only going to have one pivotal. So voter 2, you've got 5 votes, not enough to pass. But if you add 9, 5 and 9 is 14, that's over your 12. Okay, so that 9 makes it pass. That corresponds to voter 1. Voter 2, 3, 1 in that order, 5's not enough to pass. So then you consider 5 and 4. That's 9, still not enough to pass. So now you do 5, 4, and 9, which is 18. You had to get up to those 9 votes to pass. That's voter 1. So voter 1 is the pivotal. 4 is not enough to pass, but then 4 plus 9, if you add the first 2, you get 13. That is enough to pass. So those 9, which belong to voter 1, pushed it over. So voter 1 is pivotal. 4 is not enough to pass. 4 and 5 is 9, not enough to pass. So now 4 and 5 and 9 is 18. Those last 9 votes pushed it over. So voter 1 is pivotal. Okay, so then the Shapley-Shubik power index, the symbol is SS, and then we do it for voter 1, and we do Shapley-Shubik for voter 2, and then we do Shapley-Shubik for voter 3. And all the bottoms of these fractions are going to be the same. There are 3 voters here, okay? So you do 3 factorial, which is 3 times 2 times 1, which is 6. And that's actually these 6 rows. That's what the denominator is. So this is 6, this is 6, and this is 6. And then the power index is how many times is V1 pivotal. So count the V1s in the last column. 1, 2, 3, 4. So 4 out of 6. And if you want to change that to a decimal, 4 divided by 6, 0.67. That's rounded to 2 decimal places. For voter 2, they're only pivotal 1 time out of 6. So that's 1/6. 1 divided by 6, about 0.17. And then voter 3, pivotal once out of 6, so this is 1/6, which is again about 0.17. And if you add these guys up, they should be pretty close to 1.0. So 0.67 plus 0.17 plus 0.17, 1.01. So we're just rounding error. Okay, so we're good. So 2/3 of the vote, 1/6 of the vote, and 1/6 of the vote in terms of power for Shapley-Shubik, but for Banzhaf they were 60%, 20%, 20%, 3/5, 1/5, 1/5. So a little bit different power distribution that they're giving us here. So okay, so for the actual exam, you can expect something very similar. So what I would try and do is I would try and go back and take the blank version of this exam and try to work through all the problems without looking, at the answers, and make sure that you can do this on your own without looking at anything. If you can do that, you should be in good shape for the exam.